All right, let's talk about an aircraft that's more than just a plane. It's a classroom with wings. This is the Diamond DA42. And honestly, it's a state-of-the-art learning machine designed to create the next generation of pilots. So what's the big deal? How is this plane such a game changer for someone learning to fly? Well, that's exactly what we're going to unpack in this explainer. We're going to look at everything from its heart to its brain to find out. Let's get into it. Okay, so first things first, let's look under the hood, at the heart of this machine, its engines. And these are not your typical airplane engines. That's for sure. We are talking about advanced diesel power, and this is where a lot of the magic really happens. Now, you're looking at some numbers straight out of the flight manual. Max continuous power at 2,300 RPM, specific temperature limits for the oil and coolant. So what does all this technical jargon really mean? It's simple. It means these engines are built to be incredibly reliable, with very clear, safe operating limits. And when you're a student pilot, trust me, reliability is absolutely everything. So how do you manage these awesome engines? Well, here's the thing. You kind of don't. The plane does it for you. It has a system called FADEC, which is basically a computer brain for each engine. It handles all the complex stuff, like the fuel mixture and propeller pitch, automatically. This is huge because it lets the pilot focus on, actually flying the plane. And speaking of the engines, let's talk about what they drink. This thing runs on diesel or jet fuel. Now, why is that such a big deal? Because most training planes use this really expensive fuel called avgas. By using diesel, the DA42 is not only way more fuel efficient, it makes the entire process of learning to fly more affordable. That's a massive win. Okay, so we've covered the heart. Now let's move on to the brains of the operation. We're talking about the cockpit, specifically the Garmin G1000 system. If the engines are the heart, this is the central nervous system. Yeah, welcome to the glass cockpit. Seriously, forget all those old-school steam gauges and countless dials you might have seen in movies. This is clean, it's digital, and for a new pilot, it's like jumping straight into the 21st century of aviation. So what makes this system tick? You've basically got two main screens. The one right in front of the pilot is the PFD, the primary flight display. Think of it as your new best friend. It shows your speed, altitude, and everything you absolutely need to know to fly. The other one, the MFD, or multifunction display, handles everything else: maps, engine data, navigation, the whole shebang. They work together to give you this amazing, intuitive picture of everything that's happening. And don't just take my word for it. The flight manual itself calls it a fully integrated system. That's the key phrase right there. It means everything: flight info, engine status, communications, navigation. It's all talking to each other, all in one seamless system. And why does that matter so much? Because this is exactly how the cockpit in a modern airliner is set up. You're not just learning to fly, you're learning to fly like a pro from day one. All right, heart, check. Brains, check. Now it's time to talk about the body itself. We're getting into the nitty-gritty of performance, the specs, the hard limits. These are the numbers that tell a pilot what the aircraft can, and more importantly, what it can't do. Every plane has its own rules, and for pilots, those rules are written in speed. You see that VNE, 194 knots? That's the absolute red line. You never, ever go faster than that. VNO at 155 is your normal cruising speed limit. But the one I really want you to notice is VMCA at 68 knots. That is your minimum controllable airspeed if one engine fails. In a twin-engine trainer, that number isn't just a suggestion, it's a lifeline. And here's another critical number every pilot lives by: 1,785 kilograms. That is the maximum weight this plane is allowed to be at for takeoff, period. That number includes everything: the plane, the fuel, you, your instructor, any bags, all of it. Every single pre-flight calculation is done to make sure you are not 1 kilogram over this limit. So just how big is this thing? Well, its wingspan is about 44.5 feet, and it's around 28 feet long. It's not a massive plane by any stretch, but its design is just so incredibly sleek and efficient. You can just look at it and tell it's built for performance. Let's break that weight down a bit more. The plane itself, empty, weighs 1,250 kilos. That leaves you with 535 kilos of what's called useful load. That's your budget, basically. You have to fit your fuel, your passengers, and your luggage all within that 535 kilo limit. And that right there is the puzzle every pilot has to solve before every single flight. Okay, so we've looked at the heart, the brain, and the body. We've talked engines, computers, speeds, and weights. Now it's time to put it all together. What does all of this really mean? Let's answer that big question we asked at the very beginning. Let's put ourselves in the pilot's seat for a second. You're a student, you're just learning the ropes. What do all these fancy features and technical specs actually mean for you, right now, up in the air? What's the real-world difference? It really boils down to four huge things. One, flying is simpler. That FATIC system means you can focus on the big picture, not tiny engine adjustments. Two, you're preparing for the airlines from day one because the G1000 cockpit is what the pros use. Three, it's just cheaper to fly, thanks to those efficient diesel engines. And four, it's safer. You've got two engines and a smart cockpit that's always watching your back. You add all that up, that's what makes it a game changer. So, at the end of the day, the DA42 isn't just teaching students how to fly an airplane. It's preparing them for the very future of aviation. It's a direct pipeline to a professional career in the cockpit. And that really makes you think, doesn't it? As aircraft get this smart, how does the very role of the pilot begin to change?